This is the second part of Chapter 8, Phonemic Analysis. Now we're getting into what linguists do all the time. And SLPs don't do it as much, but I think it's a good skill to know because if you are working with multiple languages, it will help you in kind of decoding what kids or adults say or do and why they might have difficulty saying or producing certain sounds or reading them. So, identifying the underlying form. We're going to actually go through kind of a formula of how to do that. And then in another video, I'm going to actually try and do the process so you can see me model it. Which allophone or the surface form represents the phonemic level. So if you notice in the back of this chapter, they actually have languages and lists of words. And so you're going to analyze the context of those phonemes or the phonetic level, and then trying to determine is it a phoneme or is it not a phoneme? Is it a minimal pair? Is it not? What has the widest distribution? It occurs in the most largest number of environments. So, like the rule for N, you can have an N in the beginning, middle, or final part of a word. So, what's the largest number of environments that it's in? Then you specify the distribution of the allophone, what's constrained and what's predictable. So it's kind of like decoding. You're kind of trying to figure out what phonemes go together and what don't. Naturalness, the definition is things we might expect to occur. It's also found across multiple languages. I can only really speak to English. I haven't studied a lot of other languages. My French from high school is a long time ago. Phonetically similar, and the process is natural. So for us, saying a at the beginning of a word is not very natural. That's something that we don't do a lot, and I don't think other languages do either. So it has a wide distribution across languages. So it is it's naturalness. So solving phonology problems. Why do we want to do this? We're finding the phonological relationship among sounds. Are sounds allophones of the same phoneme, or are they allophones of different phonemes? Are, let's say, three different sounds, X, Y, and Z, in complementary distribution, or are they in contrastive distribution? Complementary distribution is allophones. Contrastive distribution is phonemes. Hopefully I said that right. So when you're solving phonological problems, you want to look for the obvious. What are things that kind of pop out at you? And some of the rules that govern that language. Make separate columns for each sound and list all the environments that those sounds are in. Examine the list. Look at the sound preceding and the sound in question. Look at the sound following the sound in question. So you want to look at before and after the sound and what are the characteristics of that. If you don't see anything obvious, extend your search to non-adjacent sounds. So maybe, there's a T and an E and an R. Maybe the T and the R are related somehow. I'm just pulling out an example. Determine whether or not the occurrence of the particular sound is predictable. So, kind of make a rule and then go through and look through the other words and see does your rule stand up or does it not? There actually is a really nice flow chart in your handout that goes through these questions. Step 1, are they minimal pairs or near minimal pairs? Yes, they are different phonemes. No, you keep going. Make a separate column for each sound and list the environments. Step 3, examine the list and ask questions such as what kind of sound comes before, what kind of sound comes after. It's kind of that process of elimination. Then you go to step 4. Is the occurrence of the sound predictable? If it is, they are allophones of the same phoneme, and state the rule that it's used in. No, they are different phonemes. So there's two different ways to get different phonemes. And this is a great way to go through some of those exercises at the back of your book. When you're stating the rules, formulate a hypothesis. You've done that a lot in school. Think of what the rule might be. I think it might be this, that a only follows t and b in this language. Excuse me. There are different environments mutually exclusive. It could be that they cancel each other out or they kind of mix together. If the two lists of environments intersect, let's say Y and Z, they cannot be allophones of the same phoneme. They're different phonemes. Allophones are usually phonetically similar sounds. So I don't think you're going to have a p and a g going to be an allophone in a language, or a sh and a t. They're going to be different enough that they're not going to be allophones. Then you state a rule as generally as possible. You want to keep it as broad, so you don't want to say a only comes after t, because that's not a very general rule. You want to say, you know, a can follow t and maybe other phonemes. So you want to be as general as you can. The more specific you get, the less transferable it is to other instances. I also want to look for natural classes. Try to use a narrow definition of natural class. Probably, I'm not thinking of an example for that. I mean, she gives there's an example here of voiced obstruents. Now, when you're stating the rules, you actually use kind of a code, and you can say sound A becomes B between X and Y. So I'm going to actually show this to you. A becomes B in the environments of between X and Y. So think of the nasalization rules. When a nasal is close to a vowel, the vowel becomes nasalized. Think about nap, ban, mom. It actually usually precedes the vowel and makes it more nasal. So, you know, there are some rules that we have in our language that change the allophones. Aspiration is the same thing. If there's certain sounds that precede or follow it, you might aspirate it more. So, that's the end of Lecture 8.